The next unit is about trigonometry. Angles are a huge part of trigonometry, so we're going to begin by looking at angles and how to measure them in both degrees and radians. We're also going to think about angles being on the unit circle. So the first big question that we have is, how do you convert between degrees and radians? Radians is the distance all the way around the unit circle. Since the unit circle has a radius of 1, the distance all the way around the unit circle would be 2 pi times the radius, which is 1. So the distance all the way around the unit circle is 2 pi. The convenient conversion is that halfway around is 180 degrees. It's also pi radians. So we can use this conversion. We can use 180 and pi, the only two numbers you have to know, to convert between degrees and radians. You might put your fraction upside down, depending on what you're converting to. So if I'm converting from radians, I'm going to put radians on the bottom, and I'm converting to degrees. If I'm converting from degrees, I'm going to put degrees on the bottom and radians on the top of my fraction. So I'm converting 150 degrees to radians. This is called dimensional analysis. I want the degrees to cancel. There's 150 degrees on the top, and I want my degrees to cancel, so I want 180 degrees to be on the bottom so that our degrees can cancel. Sorry, just the degrees, not the 180. And then I can also reduce 15 and 180, 150 and 180. First, I'm going to divide both by 10, so I have 15 over 18 pi, and then I notice that they can both be divisible by 3, so I'm going to divide by 3, and I get 5 over 6, and usually we just write the pi on top. That's kind of a convention. We don't always write the word radians when we measure our angles this way, but that is the units that we're using. So if you see an angle measurement that doesn't have units on it, and often it will have a pi in it, that means that you're measuring in radians. So we're trying to convert 3 pi over 5 to degrees. I'll give you a minute to try this problem and then come back after you've given it a try. Remember, if we're trying to convert from radians, we want the radians in our conversion to be on the bottom so that they can cancel. Analysis, I put my radian 180 over pi as the fraction I'm multiplying by because I want the radians to cancel. And then I reduce my fractions and I get that that's 108 degrees. The other way that we measure angles when we're using degrees is degrees are kind of big, so we split them up into minutes and seconds. A minute, just like with time, a minute is 1/60th of a degree. So 60 minutes is 1 degree, and a second, 60 seconds make 1 minute. So that is the other conversion that we're going to use for converting from minutes to seconds to decimals. So we're going to do, we know it's going to be 48 point something, and we're going to figure out our minutes and seconds from there. So 30 minutes, and I want my minutes to cancel, so that means that there are 60 minutes in 1 degree. So I'm going to make my minutes go on the bottom, and I have 30 over 60, which is 1/2, or as a decimal, 0.5. So now I'm going to look at the seconds, and so I have 36 seconds, and I know that for seconds it would be 3,600 seconds in 1 degree. So then we're going to do 36 divided by 3,600, or 1/100th of a degree, or if I write that as a decimal, 0.01. So now if I add that all together, I have 48 degrees plus 0.5 degrees plus 0.01 degrees, or 48.51 degrees. And that is converting from degrees, minutes, seconds to a decimal describing that angle. I'm going to give you a minute to try this one. We're going to go from degrees to degrees, minutes, and seconds. So use dimensional analysis to try this one. We convert from, well, we know it's going to be 99 degrees still, so we're starting with 99 degrees. And then we want to look at the decimal part and convert that to minutes. So 0.37 degrees times 60 minutes is 1 degree. The degrees cancel and we get 22.2 minutes. So we know it's going to be 22 minutes. We use 1 tick mark for minutes. And then that 0.2 we're going to convert to seconds. So we do 0.2 minutes times 60 seconds per minute, and that gives us 12 seconds. We use 2 tick marks for seconds. So that's how we convert from degrees to degrees, minutes, and seconds. So coterminal angles is one way, is a way of describing angles. So you can so we always start the unit circle on this initial side with that being 0. If I go clockwise, that's the standard way, counterclockwise, that's the standard way of measuring an angle. We usually say that's 45 degrees. But I can also go counterclockwise. I can go clockwise. And if I go clockwise, I'm going backwards. So we call that a negative angle. Since all the way around would be 360, we do 45 minus 360 to get that that's going to be negative 315 if I go backwards. And then I could also go 245 and then keep going and spin all the way around again. So I could do 45 plus 360 to get that other angle, the other coterminal angle. We can actually describe angles in infinitely many ways. We could spin around negative more than one time. We could spin around multiple times, but all of those angles would share the same terminal side. At these 3 angles, we want to decide which angle is not coterminal with the other 3. The way we can test it is by adding and subtracting 360 degrees. I'm going to start with the 72, and I'm going to do 72 minus 360, and that gives me negative 288. So these two are coterminal. And then if I do 72 plus 360, I get 432, but that's not one of my options. So I'm going to add another 360, 432 plus 360, and I get 792 degrees. Oh, so this one looks good. 252 is the one that is the misfit because it's not 360 degrees away from 72. It's less than that. So if I'm looking at listing some positive and negative coterminal angles, I'm going to say, well, I've got 150 degrees. 150 degrees. I can add 360 and get one of those coterminal angles, and I can subtract 360 and get the other coterminal angles. So that's my method for finding coterminal angles. Either add or subtract 360 degrees. Now, one of our answers is 510 degrees, and another answer is negative 210. But keep in mind that those are just 2 answers. There are actually infinitely many because I could keep adding 360s or subtracting 360s. But I always have to add and subtract 360. If I'm in radians, the same method applies, except I'm not going to add and subtract 360. I'm going to add and subtract 2 pi. So 3 pi over 5 plus 2 pi. If I make those into like fractions, right now this is 2 pi over 1, so it's going to be 3 pi over 5 plus, I'm going to multiply by 5 over 5 to get a like denominator, 10 pi over 5, and we write that as 13 pi over 5. So that's one option, and then the other option is we can subtract 2 pi. I'm going to write that as 10 pi over 5 because I've already found that common denominator. So my other answer is negative 7 pi over 5. Arc length is a way of figuring out what portion of the circle we have. If If 2 pi r would be the circumference of the whole circle, or the length of the entire circle if I straightened it out. And if I have a certain number of radians, like if I have pi radians, or I have theta, which is a Greek letter that we use to stand for angles, I have theta radians, I know that all the way around would be 2 pi. So this part is really the fraction of the circle that I have when I'm finding arc length. And then the 2 pi's cancel, so I wind up with the formula for arc length, which is just r times theta, because those 2 pi's cancel. If I'm measuring in radians, that makes it a pretty easy measurement, so I'm just going to do 70 radians times 1 centimeter, and that's my arc length, which would be 70 centimeters. If I'm given the arc length and I'm trying to find the angle, then I just have to do a little bit of algebra. So I have 4 inches is the arc length, and then I don't know the angle, so I'm going to call that theta. Just the convention is we use we use Greek letters for angles, and then I have 7 inches. So if I divide both sides by 7, I get that theta is equal to 4/7. And thinking of dimensional analysis, our inches cancel when we do that, so we wind up with a measurement with no units. And remember, radians doesn't really have a unit when we use it. This type, again, we have the arc length, which is 2.5 centimeters, and we have the angle, and we don't have the radius, so we're trying to find the radius. So we're going to divide both sides by pi over 3, or another way of saying that is we're going to multiply both sides by the reciprocal, 3 over pi. So the radius is going to be 7.5 divided by pi centimeters. Another way of writing that, just to make it prettier, would be you could write it as 15 over 2 pi by multiplying both top and bottom by 2, so that you don't have that weird decimal, but I would accept either answer. Find the radius if the arc length is 40 and the angle is 20 degrees. Well, before I use this nice formula, I need to change 20 degrees to radians. So remembering our one conversion is that we have 180 degrees, which I want to be on the bottom, so the degrees cancel, is pi radians. So we cancel that, we get pi over 9 radians. And then we can use our formula. So we have 40 centimeters is equal to pi over 9 times the radius. And then we multiply both sides by the reciprocal, so our radius is going to be 40 times 9 over pi. And 40 times 9 is 360 over pi. And that's going to be our radius for that problem. All right, so this unit was about different ways of measuring angles. It was about finding coterminal angles, and it's starting to think about the unit circle, and that's what tomorrow will be all about. Thank you so much. Bye.